So guys, this is an obstacle avoider robot. You can see here there is a ultrasonic sensor in front of the robot that detects the obstacle. So this one is the obstacle, and from this side also there is an obstacle over here, and another obstacle is this. Okay, let's on this. Everyone, today we are gonna learn about how to make a basic chassis. So you can see here, this is a package of chassis designed in acrylic form, acrylic body. Okay, so you have to remove this file. After unwrapping the file, you can also remove this this brown part also. This is for this is the protecting layer of the acrylic so that the scratches cannot become here on this. You can see here is a beautiful, cool model of acrylic basic chassis. You can see this is a proper transparent chassis. Okay, so you can remove all this after making the bot, but before that we should not remove before making the bot because the scratches may come on this surface. Okay, so guys, first of all you need to add some wires with these terminals of the motor. Okay, these are the two wires. Red one is for one terminal and black one is for another terminal. Okay, these two wires are to be attached here. Okay, so first of all we will attach the wires. Just trim it. Okay, you have to remove the upper one and insert it like this. Done. We are done with the first terminal of the battery. Similarly, we have to attach this black one with this terminal, and so on, like this. Similarly, for another motor, we have to attach these two wires, the remaining two wires. These are the remaining two wires. Okay. So guys, we are done with these two motors. We have attached two terminals of this motor with the two wires. Okay, so guys, now we are attaching with these motors. Now we are attaching these motors with this chassis. We need these two hinges. First one to come here like this. And second one will have to this. See guys, these voids are for attaching this, so the growing part will stop this from falling down like this. Okay, similarly this side was also some groove-like structure, void cavities for removing this. Okay, so after doing this, we have to attach. Keep this in mind that the wire should be this side. Okay, not the outside. They should be inside of this chassis, so that we can. So guys, it's the time for using these bolts. These bolts are to be attached here like this. Here you can see the bolt is coming out from this point. Okay, so now you have to put the nut in this. Similarly, take another bolt and try to insert this from this hole. Okay, like this. Okay, use this nut. Okay, now if you want to tighten it, to tighten this bolt, these bolts, you need this screwdriver. Okay, you have just hold this with this, like with your fingers, and tighten it like this. Okay, similarly this end. Okay, so half part of this bolt is done now. Okay, now it's time for another part. Similarly, the another part is to be done like so. Guys, now you can see here the half part of this bolt is done. Okay, done with the first part of this bolt. Okay, so now we have to attach this caster wheel under the chassis. Okay, this one is for controller and all. Okay, and this side is for caster wheel. This is the bottom part of the bolt. Okay, now you can see here we need these kind of bolts to attaching this caster wheel. Okay, insert it like this, and we need a nut for tighten it from this bottom part. Similarly, now you can attach this bolt, and you can tighten with this screwdriver. Okay, we are done with this first step. Okay, you don't need to connect all these screws. Okay, the two can also hold this properly. Okay, so guys, now it's time for attaching this power supply with this board. Okay, now you have to attach this with the bottom part of this board. Okay, here is the bottom part. Here you can see the two holes. There are two holes which are coinciding with each other with these bolts. Okay, this one, this hole, and the other one is this hole. Okay, you have to use these two bolts like this, and secondly, at the other side you have to use this longer screw, this longer bolt nut. This will use as a platform for attaching the motor driver. Okay, in the later steps. Similarly, you have to cover this hole also. So guys, we are done with this attachment of this battery power supply to the watt. It's time for attaching this switch that will operate as a on off switch of this board. Okay, this is a on off switch. You can see here it has two states. Okay, so you have to put this switch in this, you have to insert this switch like here, like this. Okay, now there is a separate void for attaching this field. Okay, you can see here it is just surface to surface touched. Now you can now you have to cut this wire. You have to cut this wire into two parts with the help of this. Okay, it should be sufficiently long so that it can be attached, the one end from this end and one end from this side of this terminal of the switch. We are done with this. Okay, now you have to trim it. After trimming this, you have to insert the wire opening in this terminal of the switch. Okay, you can use some sharpen object like this for attaching this. So we are done with this first terminal. Okay, now we have to attach this second wire in this second terminal of the switch. Okay, similarly there are two wires. First one is for positive, red one is positive, the second one is ground, that is negative. Okay, you have to use these two holes for passing these two wires, positive from this side and negative from this side. Okay, done. There are two wires for power supply. Okay, here you can see these are for motors. Okay, now okay, so guys, it's time for adding electronics to the watt. Okay, this one is motor shield L293D. You can see here L293D module, and another one is Arduino UNO. Okay, so guys, we are attaching this motor shield with this board. So guys, L293D should be attached here so that the wire can be attached like this in this terminal and this terminal also. And similarly, from these two ends, these two holes, we have to pass these two wires so that it can be reached properly. The wires can reach properly to the destination, that is to the terminals of this, like this. Okay, now you have to lose these bolts, and now you have to insert these two wires inside this. Okay, but before that you can turn around these two wires. So guys, now we are done with this attachment of this motor shield. Both the motors get connection with this L293D, that is motor module, motor driver shield. Okay, it's time for attaching this Arduino on this board. Okay, so again you have to use these long screws, and with the help of this you have to attach this Arduino. Guys, here you can use this connector also for powering up this Arduino with this jack. Okay, like this. So these two ends should be attached to this supply that is coming from the bottom part of this board. Okay, you can just add like twisting with this wire, twisting these wires like this. Similarly, the red one, that is positive, so guys, now our Arduino is powered up with this. Okay, now it's time for attaching these two wheels. First one is like this. As I told you, this is just plug, insert and use it. Okay, this is done. This is the basic board. This side view of this board. Okay, the bottom part of this board. All looking fine. Okay, these two are used for seeing the speed and the direction of the motors. Okay, you can use the free end of this shaft, motor shaft, in inserting this. Okay, but right now we are not using these two circles. Okay.
Okay, hello everyone. Now we are going to make a obstacle detector using ultrasonic sensor. So this is the same chassis that we have used in line follower. Connections are same, and now we are replacing that IR sensor with this ultrasonic sensor. Okay, motors connection and power connection are same as they were before. So now we are going to connect this ultrasonic sensor. So I am giving VCC, so this comes VCC. Instead of giving VCC from Arduino, I am giving VCC from L293D. I can do that because Arduino and L293D is connected to each other. So now I am connecting VCC to ultrasonic sensor. And then comes ground. Ground is from Arduino board. Okay, and then eco pin is connected to pin number 8, and trigger pin is connected to pin number 9. So this completes our connection. Now I will stick this sensor using a double-sided tape. So connection and assembling is complete. Now we will program this robot. So first we will declare pin mode. We have motors connected on pin number 3, 4, 5, 6. So pin number 3, so this is pin number 3, pin number 4, 5, 6, and pin number 8 is trigger, and sorry, pin number 8 is eco and trigger is 9. So pin number 8 goes input, and pin number 9 as output. So our pins are declared. Now we are going to program this. So first of all we need to take distance input in our ultrasonic. So for that we will set trigger pin to low. So digital write 9 comma low, and then same thing, delay in microseconds, 2 microseconds, and then high, then again low. Okay, now we will declare variables long du for duration and dist for distance. For du we will write pulse in, then pin number 8, that is our echo pin, and I. So duration is stored in du. Now for distance we will write a formula. Distance is equals to du by 2 divided by 29.1. Okay, so according to our requirement, when distance becomes less than a specific value, that is, say in this case I am using distance is equals to 10. So when distance becomes less than 10, the robot should stop and turn. So for that I will write if distance less than, say, 10, then our robot should stop. So to stop this bot I will write digital write 3 comma low and same 4 comma 5 comma and 6 comma low, 4 comma low, 5 comma low and 6 comma low. So our robot has stopped, and then I will give a delay. So delay of, say, 1 second. So our robot will not move for 1 second, and then I will turn this. So for that I will write uh, 3 goes high and 6 goes high. So this is the command to turn. Okay, so this robot will turn for 1 second, and then it will continue to move. So when distance is more than 10 centimeter, less than, or say here less than or equals to, now in case, now if distance is more than 10 centimeter, the robot should move forward. So in this case high, and this also becomes high. Okay, so this completes our programming, but if we want we can make some modification. Say after detecting an obstacle the robot should stop and then it will move backward. So if you want to do that I will write, so this command is to stop a robot, and this command will move a robot in backward direction. Okay, so now when distance becomes less than 10, robot will stop, then it will move backward for 1 second, and then it will turn for 1 second, and else if distance is more than 10, then it will move forward. So that's it. Now we will test this program. So first of all I will program this. Semicolon. So now we will test our robot.